Here we have a very important question that we refer to as splitting an equation. And this question type has an entire theory behind it. Now, a reminder that you should know is that for intersections, you should be getting both equations in the y equals format and setting them equal. Why are we talking about this here? Because the opposite is actually true. If we see two equations set equal to one another, if we see two expressions set equal to one another, we can imagine that maybe each of these are their own equations. And what we're looking at is an expression of them intersecting, or someone trying to figure out where do these two things intersect. So they did this, they took them and they set them equal. So imagining that out, we can say, well, what if one of them looked like this and the other one looked like this? And we're being asked about where do these lines intersect? And when we asked that question, what did we find? We found that there were no solutions. So everything in here is a reference to an idea, all important ideas when it comes to the SAT. But the next idea that seems to be coming up is the idea of the number of solutions for two lines. If you have two lines, there are, let me make this a little neater. If you have two lines, there are three ways they can interact with one another on an XY axis. The lines can hit once, they can hit never, or they can hit all the time. And if they hit once, it would happen if the slopes are different. If they hit never, it would happen if the slopes are the same, but the y-intercepts would be different. And if they hit all the time, it's because the slopes and the y-intercepts were both the same. Everything is the same. They're the same line. They're hitting all the time. So now in our situation with no solutions, we're seeing that it would be this situation. If we're imagining that these are two separate lines and there's no solution, it means they never hit. In other words, the slopes are the same. So to make better use of that, let's clean up the second one. Let's distribute the a. Y equals ax plus ab. So this is in your classic y equals mx plus b format. So we know that the slope is the a in front of the x. And the slope for us in the equation on the left is the 9. So if, according to the rules for the number of solutions for two lines, if the slopes need to be the same, then a and 9 have to be equal to each other. So we just showed why a has to be equal to 9. But in addition to the slopes being the same, the y-intercepts must be different. And what are our y-intercepts? For the first line, the y-intercept was 5 because it's mx plus b, 9x plus 5. And for the second, the y-intercept is the AB because it's mx plus b, mx plus AB. So by the way, we're using the letter B for two different things, which is a really common thing on the SAT. So that's our y-intercept right there. And we know that that y-intercept right there cannot be equal to 5. If it is, it would be infinite solutions where the slopes and the y-intercepts are the same. So in addition to a being equal to 9, AB cannot be equal to 5. Taking that even further, well, we know what a is. It's equal to 9. So 9b cannot equal 5. And if we treat this non-equality here as an equation, we can divide both sides by 9. And we can say b cannot equal 5 over 9. And so we have our two answers. A has to be equal to 9, but b cannot be equal to 5 over 9. So that's 1 and 3, which is answer choice D here.